Welcome to today's numeracy tutorial. Our learning objective today is to begin to understand what equivalent fractions are. So far we know how to identify fractions, knowing that any whole amount can be split into equal parts, and we show this by writing fractions. A fraction is a special number that is made up of a line and two parts. The numerator is the number that goes on top of the fraction line, and the denominator is the number at the bottom of this line. The denominator is the number of total equal parts in the whole, and the numerator is the number of parts that we're interested in. Today, we will continue to develop our mathematical understanding of fractions by learning how some fractions are equivalent to others. More of that to follow, but as always, we'll get ready for our lesson with a 5-question brain gym. Get ready to warm up. Here are your 5 questions. Pause the video now and have a go. Question 1 asks how many sevenths are there in 1? If the parts are sevenths, then we know the denominator is 7. For the fraction to equal 1 whole, there must be 7 parts of 7. There are 7 sevenths in 1. Question 2 asks us to calculate the area of the rectangle. I can see there are 3 rows of 6. I can find the area of this rectangle by multiplying adjacent sides, the length and the width, or vice versa. 3 times 6 is equal to 18, so the area is equal to 18 squares. Question 3 is a multiplication calculation. We begin multiplying the ones. 5 ones times 9 is equal to 45. Record the 5 and exchange the 4 tens. Now multiply the 3 tens by 9. And that equals 27 tens. But we need to remember to add the 4 tens we exchange so we can make 31. The product of 35 and 9 is 315. Question 4 gives us practice of rounding a 3-digit number to the nearest 10. We need to look at the ones digit. It's 7, so we'll round this number up to the next multiple of 10, which is 350. Question 5, as always, is our time question. This time, we must look closely at where the minute hand is pointing. The minute hand is pointing past the 1, which would be 5 minutes past. It is pointing to 3 notches after the 5-minute mark. This tells us that it's 8 minutes past the hour. The hour hand is pointing to 12, so the time is 8 minutes past 12. We write this as a digital time left to right, 12:08. Notice that we don't just write the number 8. A digital time will always have 4 digits. Now we're ready to focus on our learning objective for today. Today we are thinking about the word equivalent. Pause the video and have a think about what this word means. Equivalent means of equal value, amount, or meaning. Let's look at some examples. £5 coins are equivalent to one £5 note, because both are £5. They are the same value. Another way to look at equivalent might be to say 3 add 3 is equivalent to 5 add 1. 3 add 3 is 6 and 5 add 1 is 6. Another way to think about the word equivalent is we might think about measurement, where 1 metre is equivalent to 100 centimetres. Well, I can't fit a picture of a full metre stick on this side, so instead I can show you that 1 centimetre is equivalent to 10 millimetres. In today's lesson, we are thinking about equivalent fractions. Equivalent fractions are fractions that are the same size. They are equal, equivalent. Let me show you what I mean. Here we have a bar which I'm going to divide into 2 equal sections like this. Each section of the bar is equal to half the bar. You can see 1/2 shaded. Here's another bar. This is the same size as the first. This time I'm going to divide the bar into 4 equal sections, or quarters. If I shade in 2 of the quarters, can you see that they are the same size as the half above? The half is the same as 2 quarters. So we can say 2 quarters is equivalent or equal to a half. Here's a practical experiment for you to try at home. Get a strip of paper and carefully fold it in half. Press down hard on the crease so that when you open the strip out, you can see where the halfway is marked. You could now colour in 1/2 of the strip. Next, fold the same strip in half again. That should be easy because the paper is already creased. And now carefully fold the strip in half once more. Just like before, press down hard to make the creases. When you open the strip out, you should notice that half the strip is actually the same as 2 parts of 4. Pause the video and try this at home. Here we have our bar, and it's divided into 4 sections. Quarters. 2 of the quarters are shaded, which we now know is equivalent to half. But what if we took another bar of the same size, and this time we divided the bar into 8 equal sections? This time each section is 1/8. If we again shade half the bar, how many eighths are equivalent to a half? Pause the video and have a think. 2 quarters is equivalent to a half, and 4/8 are equivalent to a half. They are all the same. Now let's take a look at 2 bars of equal size together. If I divide the first bar into 3 equal sections and the second bar into 6 equal sections, can you find the missing numerator? How many sixths are equal to 2/3? Pause the video and have a think. The first bar is divided into thirds, and you can see that 2 of those thirds are shaded in. The second bar has been divided into sixths, and we have shaded 4/6. Here we have shown that 2/3 is equivalent to 4/6. Just as before, you can conduct a practical experiment with a strip of paper to prove that 1/3 is equivalent to 2/6, or similarly that 2/3 are equivalent to 4/6. Pause the video and follow the instructions to have a go. Let's explore more equivalent fractions. Here we have our bar and it's divided into thirds, just as before, but this time our second bar has been divided into 12 equal sections, or twelfths. How many twelfths would be equivalent to 1/3? Pause the video and have a think. If we look at one of the 3 parts that's been shaded in, then we can see the area of equivalent twelfths is 4/12. Now if we look at the second third, we can see how many twelfths will be equivalent to 2/3. 2/3 is equivalent to 8/12. And now lastly, if we look at 3/3, can you see that I've shaded 12/12? As well as comparing fractions side by side, we can also see equivalent fractions within a bar. Here we have a bar and it's been divided into twelfths, just like before. There are 12 equal sections. We have 4/12 shaded. Can you see what equivalent fraction of the bar this is? Pause the video and have a think. Here we can see there are 2 more blocks of 4 sections, making 3 sections altogether. We can see that our 4/12 is actually equivalent to 1 out of 3 of these sections, making 4/12 equivalent to 1/3. This time we have 3 bars of equal size, but they have been divided into different numbers of equal sections. The first bar shows fractions with a denominator of 6. The second bar shows fractions with a denominator of 3, so thirds. And the bottom bar shows fractions of a denominator of 10, so tenths. Flora says, I could use any of these bar models to show 1/2. Is Flora correct? Pause the video now and have a think. Let's have a look together. First, I will draw another bar of equal size and shade in half to compare. If we shade 5 sections of the bar with 10 equal sections, then we can show a half. 5/10 is equivalent to 1/2. If we shade the bar with 6 equal sections, we can show a half by shading 3 out of the 6 sections. So 3/6 is equivalent to a half. But if we shade the bar with 3 equal sections, we cannot show a half. We can see that 1/3 is not equivalent to a half. Today our learning objective was to know more about what we mean by equivalent fractions. We've learned that equivalent means equal or the same as, We've also spent time examining equivalent fractions using a bar. We discovered for fractions to be equivalent, they must be equal amounts, but that equivalent fractions have different denominators and numerators. Greg asked us a question at the very beginning of our tutorial today. Do you see it? What's the same and what's different? He says these fractions are equivalent. He says, although the denominators are different, we can see they take up the same amount of the bar. 1/3 is equal to 2/6. Guys, you spent a lot of time today working through challenges, so now you're ready to go and complete your independent task. As always, good luck!